Hey, hi everyone. Hope you all are doing well. Welcome back to live streaming with Team Axiom. Today's agenda for live streaming is to discuss about all the software application architectures available, their pros and cons. So my team will explain you the various architectures, the microservices architecture. After that, we'll be going with the REST API authentications because nowadays all the type of applications are basically REST API based. So how REST APIs do the authentications and what is the entire process of authentication, that will be explained by my team. After that, we'll be discussing with the API testing. Obviously, we are using various API testing tools. After backend developers develops the APIs, before going for the integrations, we need to test for the responses, and then we'll go with the integrations. So what procedures will be going to follow for API testing, right? What are the various ways and types of API testing that will be discussed by the team. And finally, we'll be going with a discussion of how we'll manage the code, how the like software companies ship the code from uh, like you are designing to development to deployment sort of. So how the code will be securely managed, how the uh, code will be transport shift from one phase to other phase, right from the designing to front end development to back end development to quality testing to like either by following all the scrum meets, by dividing the code and integrating together, and then through the CI/CD pipelines, how the deployment will be done of that code and how it will be securely done. What do you mean by exactly code review and all? They're all things we are going to discuss in today's live stream. Hope you get the glimpses about the agenda of today's live stream. Let's open this forum for Team Axiom to discuss this all the phases of today's application architectures and API testing and authentications. Right, over to Team Axiom.
Very good morning, one and all. Myself, Saloni Singh. I am here to present on topic software architecture. Software architecture is a set of structure needed to reason about a software system and discipline of creating such structures and systems. Each structure comprises software elements, relations among them, and properties of both element and relations. Software architecture also defines a list of things which results in making many things easier in the software deployment process. A software architecture defines structures of system, behavior of system, component relationship, communication structure. A software architecture also balances stakeholders' need, influences team structure, focuses on significant element, and captures early design decisions. These are the contents which we are going to discuss. There are several software architecture patterns which we are going to discuss. So now the question arises, what is software architecture patterns? Software architecture patterns plays a crucial role in its ability to scale and meet users' demand over the time. An architectural pattern is a set of architectural design decisions that address recurring design problems in various software deployment contexts. It offers rules and principles of organizing the instructions between predefined subsystems and their role. There are several architecture patterns, but famous examples of architecture patterns are microservices, message bus, service requester, or consumer, MVC pattern, MVM, and many more. Next question arises, why software architecture is used? Software architecture is basically software engineering help to expose the structure of system while hiding some implementation details. Architecture focuses on relationships and how the element and component interact with each other, as does the software engineering. The software architecture of system represent the design decision related to overall system structure and behavior. Architecture helps stakeholders understand and analyze how the system will achieve essential qualities such as modifiability, ability, and security. Moving towards a different type of software architecture pattern. Here are some architecture patterns which we are going to discuss. Hope you all understand what I am trying to explain. MVC architecture pattern, layered architecture pattern, event-driven architecture pattern, monolithic architecture pattern, microservices architecture pattern, master-slave architecture pattern. These are some architecture patterns which we are going to discuss. First of all, MVC architecture pattern will be demonstrated by my team member Himanshu. Over to you, Himanshu.
So now we will discuss about the MVC architecture. First of all, the question arises: what is MVC? It is a it contains the components such as model, view, and controller. The model view controller framework is an architectural design pattern that separates an application into three main logical components, that is model, view, and controller. Each architectural component is built to handle specific development aspects of an application. It isolates the business logic and the presentation layer from each other. It was traditionally used for the data graphical user interface, that is GUIs. It isolates the business logic and the presentation layer. Nowadays, MVC is one of the most frequently used industrial standard web development frameworks. It is used in Laravel frameworks and coordinator framework. It is also used for designing mobile apps. The main goal of the design pattern was to solve the problem of user controlling a large and complex data set by splitting a large application into specific sections that all have their own purpose. Now we'll discuss about the three components present in MVC framework. MVC framework includes these following three components, that is controller, view, and model. So what does the controller do? The controller is a component that enables the interconnection between the view and the model. So it acts as an intermediary. The controller doesn't have to worry about the handling data logic. It just tells the model what to do. It processes all the business logic and the incoming requests, manipulates data using the model component, and interacts with the view to render the final output. Coming towards the view component is used for all UI logic for the application. It generates a user interface for the user. Views are created by data which is collected by the model component. But these data aren't taken directly, but through the controller. It only interacts with the controller. Model component corresponds all the data related logic that the user works with. These can represent either the data that is being transferred between the view and the controller components or any other business logic related data. It can add or retrieve data from the database. It responds to the controller request because the controller can't interact with the database by itself. The model interacts with the database and gives the required data back to the controller. This is all about the components. And now we will see how the working on MVC framework uh, the work with the help of example. Let's imagine an end user sends a request to the server to get a list of students studying in a class. The server would then send that request to the particular controller that handles students. That controller would then request the model that handles the student to return a list of all the students studying in a class. The model would query the database for the list of all the students and then return this back to the controller. If the response back from the model was successful, then the controller would ask the view associated with the student to return the presentation of the list of students. The view would take the list of students from the controller and render the list into HTML that can be used by the browser and show to the end user. The controller would then take that presentation and return it back to the end user, thus ending the request. Uh, If earlier the model returned an error, the controller would handle that error by asking the view that handles error to render a presentation for a particular error. That error presentation would then be returned to the user instead of student list presentation. As we see from this example, the model handles all the data, the view handles all the presentation, and the controller just tells the model and view what to do. This is the basic architecture and working of MVC framework. Now, the layer architecture will be explained by Mohit. Over to you.
Now let's discuss about layered architecture. Layered architecture, also known as multi-tier architecture, or n-tier architecture. Each layer has a specific responsibility and interact with adjacent layer in a well-defined manner. This architecture style promotes some modularity, scalability, and maintainability. Here are their typical layers found in layer architecture. First, presentation layer. Presentation layer is also known as user interface. This is the topmost layer responsible for handling user input and presenting information to the user. It deals with the user interface, include graphical elements, forms, and other interaction components. Often, this layer components will be underlining layer to submit data. Second is application layer. Application layer is also known as business logic layer. The application layer contains the business logic or application specific functionality. It processed and managed data based on the business rules and required. It acts as intermediate between presentation layer into the data layer. Third is domain layer. Domain layer is also known as business object layer. The domain layer contains the business entities or objects that represent the core concept and rules of the application. Fourth is infrastructure layer. Infrastructure layer provides Fifth is data layer. Data layer is also known as persistent layer. The data layer deals with data storage, retrieval, and management. It includes data file, um, database, file system, and any other storage mechanism used to persist application data. The layer is responsible for managing the interaction between the application and the data storage. The benefits of using a layered architecture include improved maintainability, scalability, and flexibility. Changes into one layer can be made without affecting the others, promoting modular development. Adjacent is faculties the reuse of components, making it easier to update, replace specific path of the system. Layered architecture is widely used design pattern that can be found in various types of software system across different domains. Some common areas where layered architecture is include are: first is web application, and second is e-commerce platform. Layered architecture is frequently used in web application. The presentation layer handles user interaction through the web interface. The application layer contacts business logic, and the data layer manage data storage retrieval. E-commerce system can benefit from layered architecture by separating the front end in a presentation layer, business logic for handling transaction in application layer, and database interaction in data layer. Now we will explore about event-driven architecture. Event-driven architecture is a software development approach in which service are software are triggered by events, and that is why approach is known as event-driven architecture. There are three components. First is event producer, second event broker, and third event consumer. The event producer component generates event based on certain condition are triggered. Events are produced any sent to the event broker. The event broker serves as an intermediate between event producer and event consumer. It received events from producer and routes them to the appropriate consumer. Event consumer subscribe the specific type of events and react to them. They received events from the event broker and perform action based on the information received. Events are generated by the produce passed through the event broker and the consumer by one or more event consumer. The use of an event broker faculties decoupling between producer and consumer, enabling a more flexible and scalable architecture. Now let's see. Now let's see example on online shopping system. Here we have a very event-driven architecture. Imagine an online shopping platform where user can added um, items that cart. When an item is added to the cart, an event is generated and needs be processed by various components in the system. Let's see how the events will pass through components. Event producer. Event producer is also known as shopping cart service. Second is broker. Event broker is also known as message query. Third is event consumer. Event consumer is also known as in inventory service. The shopping cart service is responsible for managing user for shopping cart. When a user added an item to the cart, the shopping cart service generates an item added events. A message query service as the event broker in the example. It acts as intermediate that received and rotate event between the producer and consumer. The services is responsible for managing the available stock and items. Thus, subscribes of item added events to update the inventory whenever a new item is added to the user cart. That's all for our side. Hope you are understand different architecture. Thank you.
Good afternoon, everyone. Myself Sejal from Axiom. So now we will discuss about microservice architecture. So let's begin by understanding what is microservice architecture. It is a design approach for building software applications as a collection of loosely coupled, independently deployable services. In other words, we can also say that microservice architecture is a development approach in which large apps are built from many modular components or services. Each services is so separate code base which can be managed by small development team. Each service can be isolated and managed independently. It also supports polyglot programming. For example, services don't need to share the same technology stack, library, or framework. Previously, we have monolithic architecture. In that, the entire application is designed as a single self-contained unit. This means that all components of the application, including the user interface, business logic, and data access layer, are tightly integrated into a single code base and packaged together for deployment. For example, consider a e-commerce platform where the front-end web application, back-end service handling product catalog, order processing, and user authentication, as well as the database storing all similar data and are all bundled together into a single application. Any updates or changes to one part of application require redeployment the entire monolith. In monolithic architecture, it is all component of the application typically use the same technology stack, including programming languages, framework, and libraries. This simplifies development and deployment, but limits flexibility in choosing the most suitable tools for flexible tasks. In this diagram of monolithic architecture, we have client, component. Component includes UI, user interface, business logic, and data interface with their single database. In monolithic architecture, these components are tightly integrated and run as a single unit. Changes to any part of the component may affect the entire application. Databases store and manage the application's data. In the monolithic architecture, there is typically a single database that is shared by all components of the application. This database could be rational or non-rational depending on the requirement of the application. In a monolithic architecture, the client communicates directly with the components, which in turn interact with the database to retrieve or manipulate data. This architecture is characterized by tightly coupling between the components, making it simple to develop and deploy, but potentially more challenging to scale and maintain as the application grows. I hope you all understand about monolithic architecture. To overcome limitation of monolithic architecture, here we have microservice architecture. In microservice architecture, it breaks down the application into smaller, loosely coupled services. Each microservice functions as an independent unit with its own data store, business logic, and interface. For an example, an e-commerce application decomposed into separate services for user authentication, product catalog, order processing, payment handling, and recommendation engine. Each services can be deployed, developed, and scaled independently, allowing the greater agility and scalability. Services can be deployed, developed, and scaled independently for one another, allowing teams to work autonomously. Microservices also allow for each service to use its own technology stacks. For example, if we are building e-commerce application, in that we have user management service. It might be implemented using Java or Spring Boot, while the product catalog service might be used Node.js or with Express.js, and the recommendation engine might be leveraged Python with Flex. Each services can be used the same technology best suit to its specific needs. In this diagram, we have client, API gateway, microservices with their own database. The client could be a web browser where user can interact with application. Then we have API gateway. The API gateway is the entry point for the client to access the microservices. It acts as a reserve factor, routing requests for client to appropriate microservice. It can also handle tasks like authentication, rate limiting, and load balancing. Then microservices, these are the individual services that make up the application. Each microservice is responsible for specific business function and run as an independent process. They communicate with each other. Lightweighted mechanism like HTTP or messaging file. Microservices typically have their own databases. Each microservice manages its own data store, which could be SQL or no SQL. This diagram insulates the flow of requests from the client to the API gateway, which then routes the request to the appropriate microservice. Each microservice interacts with its own database to perform the necessary operations and returns the result back to the client and the API gateway. Now we will discuss how do microservices work. So let's create an example. If we are building an e-commerce application with the following components: client, API gateway, microservices, and with their database. So client represents a web browser or a mobile app where user can browse products, add them to their cart, and place order. API gateway. The APIs are the middleware or software components that sit between the client application and backend service. The primary function of API gateway is to route and transmit client requests to the appropriate backend services. It also handles authentication and rate limiting. For example, it could be implementing using tool like NGNX, which provide open source web server software, or a dedicated service like Amazon API gateway. Microservices, the main function unit of the system. Here we have microservices, product microservices, order microservices, and customer microservice. So product microservices manage product related functionality such as product information, inventory, and many more. Second, order microservices. It handles order related functionality such as creating, updating, and managing orders. Third microservice, we have customer microservice. It responsible for managing customer information, authentication, and other customer related functionality. Each microservice has its own database. Like product microservice has product database, order microservice has order database, and customer microservice has customer database. Databases associate with each microservices. Each microservices manage its own data store to maintain loose coupling and independence. In this architecture allows for flexibility and scalability as each microservices can be developed, deploy, and scale independently. And the failures in one microservices do not necessarily affect the entire system. Additionally, different microservices can use different technologies and databases based on their specific requirement. Now we will going to discuss about example of microservices in cloud, Google Cloud. So when you use Google Cloud, you can easily deploy microservices using either the managed container service JKE, that is Google Kubernetes Engine, or the fully managed serviceless offering Google Run, Cloud Run. Depending on your use case, Cloud SQL and other Google Cloud products and services can be integrated to support your microservices architecture. So let's consider a scenario in which you are migrating a monolithic web application or developing a new one with the microservices architecture. So microservice architecture are often event driven with the pub sub model where one service publishes events and other services subscribe to the events and take action on them. In this example, we have four services: order services, notification services, packaging services, and shipping services. So, when a user places an order on the website, the order services receive the order, firstly does some processing, and then send to the Google pub or sub. The packaging and the notification services, which are subscribed to the event from the order service, and start the packaging process for the order and send an email notification to the customer respectively. The packaging service send an order packaging event to the pub or sub. The shipping service, which has subscribed to this event, processes shipping and sends an event to the pub or sub. The notification service consumes this event and send another message to the customer with order shipment information. Notice that in this example, the notification service use cloud function to run the logic for sending notification and use Firestore database to look up user email addresses. The shipping and order services are deployed on Cloud Run while the packaging service is deployed on Jenkins. They all are connected to a Cloud SQL database. Now I hand over to Rashmi for further discussion.
Thank you, Sejal. So now we will discuss about the advantage of microservice architecture. So microservice architecture offers the several advantage over the traditional monolithic architecture. So here are some advantage. So first advantage is the scalability. Microservice allows for the individual components of an application to be scalable independently based on demand. This enable the better resource the utilization and cost efficiency. The second advantage is fault isolation. Since each microservices is a separate entities, failures is the one services do not necessarily affected the entire system. This improves the fault tolerance and overall the system reliability. The third advantage is the flexibility. Microservices enables team to choose the best technology stacks for each services based on its requirements. This flexibility allows faster innovation and updation to the changing the business needs. The fourth advantage is the easy maintenance. Smaller code base and clear boundaries between the service make it easier to understand, update, and maintain the system over time. Teams can work on individually services without needing to understand the entire monolithic code base. The fifth is the continuous deployment and DevOps. Microservice architecture aligns well with DevOps practice, enabling continuous integration, deployment, and delivery. Each microservices can independently test it, deploy, and roll back if necessary, facilitating the rapid integration and experimentation. Microservice architecture offers numerous benefits such as scalability, flexibility, and many more. However, it's also come with its own set of challenges. So here we'll discuss about the challenges of microservice architecture. The first challenge is the complexity. Microservice architecture can be significantly more complex than monolithic architecture, managing the different services, each with its own code base, data store, communication protocol, and deployment pipelines can increase the overall system complexity. The second challenge is distributed system. Microservices operate as distributed systems which introduce the challenges related to network latency, partial failure, and eventually consistency. Developers need to design the robot's communication mechanism and implement fault tolerance strategy to handle these challenges efficiently. The third is the security. Microservices introduce the additional security concerns such as data display between the services, authentication, authorization, and securing inter-services communication, ensuring the power security measure across all the services and maintaining the consistency in security policy can be challenging. The fourth one is the data management. Microservices often have their own database, which can lead to data management such as data consistency, data integrity, and transaction management across the multiple services. Implementing the solution like distributed transaction or event driven architecture is necessary to address these challenges. The fifth challenge is the testing. Testing microservices can be more challenging than the testing monolithic application due to their distributed nature. It's individual the services in isolation, ensuring between services and setting up logically tested an environment can require significant efforts. So now we will discuss about the key step to deploy microservices. It is a way of design software application has a collection of the small independent services that work together. So let me break down the step for you. So first step is the service discovery. These steps involve the registration and discovery of all the available microservices within the architecture. It's ensure that the each services knows about the others can communicate with them. The second step is the API gateway. The API gateway acts as a single entry points for a client to access the microservices. Also, it's handle a request performance authentication and routes them to appropriate the microservices. The third is the load balancing. These steps ensure that the incoming requests are distributed evenly across multiple instances of each microservices. Also, it's help improve the performance and scalability. The fourth step is the service orchestration. Here, the microservices work together to fulfill a specific request. They may communicate with each other, exchange data, and performs any necessary operation to complete the request tasks. The fifth is event driven communication. Microservices can communicate with each other through events. When one microservice is published an event, the other microservices can subscribe to it and react accordingly. This allows for decoupled and asynchronization communication. The sixth is the data management. Each microservices has its own database or data store, responsible for the managing its specific data. The microservices may use the different database depending on their requirements. The seventh step is the fault tolerance. Microservices are designed to be flexible. If one microservices fails, it should not bring down the entire system. Fault tolerance technique like a circuit breakers and retry are used to handle the failure gracefully. The last is the monitoring and logging. Monitoring tools are used to collect the data about the performance and health of the microservices, and its logging help is troubleshoot and debugging the issue. This is the brief overview of all the steps involving in the microservice architecture. Its flexible and scalable approach to building software application. So here are the example of the microservice architecture. So first is the Netflix. Netflix is the well known as the example of microservice architecture. Their platform consists of the different small services responsible for their different functionality, such as user authentication, content recommendation, video streaming, billing, and many more. Each service is independently deployable, scalable, and also allowing Netflix to handle the massive amount of the traffic efficiency. The second example is the Amazon. Amazon is an e-commerce platform is built on microservices architecture. We can see the different types of services handle the different aspect of the shopping experience, including product catalog, user account, payment processing, order management, and recommendation engine. This modular approach that enable Amazon to continuously innovate and scale their platform. The third example is the Uber. Uber platform is the powered by the microservice to handle the ride booking, driver management, payment processing, and other functionality. Each services is responsible for their specific part of the business logic, allowing Uber to adapt the quickly to changing the market demands and scale their operation globally. Thank you. This is from our side. I hope you all understood about the microservices. So now I hand over to team REST API authentication. Thank you.
Thank you, team, for the well demonstration. Now, today hello everyone. My name is Sahil Rangari. I'm from Axiom TechGuru. Now we will discuss about the REST API authentication, and my team will lead on this. So over to you.
Good morning, everyone. My name is Samir Bisen from Exam Team. Today, I am going to explain about REST API authentication. In that, we will discuss on these topics, which is what is REST API authentication, why we use REST API authentication, and how to use REST API authentication. Now, these are the agendas of REST API authentication. Now we will discuss about introduction of REST API authentication. REST API authentication is a way to verify a user identity and permission to access an API. It is an essential part of any API system because it provides a secure way to control access to the API and its resource. Now, mm, in that we have four types of authentication. First, mm, first is a basic authentication. Second is a token-based authentication. Third is zero-auth authentication, and fourth is API key authentication. Now we will discuss first type of authentication, which is basic authentication. And now, what is basic authentication? Basic Basic authentication is a simple authentication scheme built into the HTTP protocol to provide a username password when making a request. When employ basic authentication, user include an encoded string in the authorization header of each request they they make. In basic authentication, we have two end. First is the client, and second is the server. In between, we have an user agent like web browser. User agent work between client and the server when making a request. Now we will go for the how to use basic authentication. Basic authentication. In that we have a diagram. First is the client and second is the server. We have an example like Facebook platform. In that client will request for the registration, then Facebook will give return response for fill the registration. That data will store on server for authentication. When the client requests to Facebook for login, then client have to enter his credential like username or password. They only server of Facebook will authenticate great access for Facebook. Now, now we will look for the advantages of base API authentication. Basic authentication. In it is lightweight and easy to implement. Basic authentication does not require cookies or a login page. You can implement it right in the HTTP header. Thank you. Now I am going to hand over to Sahil sir for the further demonstration.
Thank you, Samir, for the insightful overview of REST API authentication. Now we'll discuss about what is token authentication. This is the second type of authentication. So an authentication token is like oath token. Here we use the JWT token, which is JSON Web Token. is an API authentication method that uses token to authenticate API customers or consumers. This API authentication method uses for the JSON data structure to store authentication information for API users, such as username and the data of that particular user, and with this expiration time also. So, how does JWT token works? So, API consumers send API request to the valid username and password to the API provider. Means we already know about the two ends. Like first is the client and second is one is the server. So, client is request to the server for the particular thing and it will give back as a response to the client. Okay, so we'll move forward for why we use token authentication. So uh, this is the authentication token here, which is verified by the server. Means this is the computer generated code that verifies user identity from server. Whenever JWT authentication provides advanced security measure because tokens are cryptographically signed with encrypted code. Means we know that the random numbers or character which is assembled with this token, so they cannot be hacked by the someone. So this is token we use for this access of this data of user by server. They allow users to access these resources without having re-enter their login credential each time they visit. Means like example, we have the Facebook platform and we are going to register here. Whenever we register here, so that time only the token is generated with this random characters of a string, and that token have the details of that user. And after that, when we return back to login, so they need only the username with this authentication token for accessing this platform. So we'll move forward how to use token authentication. This is the diagram and we can clear with this diagram. So here's you can see that there is a user and the client with this authentication server. So user is sending username password. So the process is like request and the response from server. So client is requesting for the username and password to server, and it will give back with this token. And after that, the token will be goes to the resource server to verify, and it will give the resources. So move towards some code or technical part. So here's the my APIs for this registration purpose. So we have to create first API for this request and response process. Here's the my controller like register control, and I'm sending the details like name, email, and password as a request body from client to server. Like here, hope you all are understanding. And then there's a data which is covered with JWT. So you can see it here. I use here jwt.sign with the data, and the my secret key is ABC Sharif. So secret key, what is a secret key? Secret key is used for the decoding after that token. And we have the example also how to create token. So just we have the API toolkit like Postman. So we have to here uh, go to the dashboard for post method. So we need to know about the what is methods of APIs. Like we have the CRUD operations: create, read, update, and delete. So in the case we know about the name of post, get, put, and delete. So what is post? Post is the creating data with the server with using the URL of any specific API, and we have to send some data by using body. So here's the example for creating the token. First you have to select the method of testing for this creating the token is post, and the URL with this endpoint you have to need and the understand about the endpoint. This is only your standard for this creating the token. You need to focus on the endpoint with this URL. So my is the register for I use here regi, and I will send the data from postman to the server. Means I am requesting to server for the creating the user. So I have the test I will remove that, and user one with this data user one at the rate example.com, and the password I can set 321. So this is, so I am sending that data, means requesting to server for registration purpose. So after that, look here, we are given as a response like status is okay and with the token. So this is the token which is created by JWT for authentication, and it will secure our data for lacking of hacking of from the other persons or hackers. So we'll just copy it and check whether the data is secured with token or not. So we go back here, and we have the website of jwt.io debugger. So here, this is the interface where we can decode our token. Just we have to that copy token have here to paste, and you can see here in the decoded section, the here is a payload of data. Whichever data I entered to create the token for the registration, that data is seen here. Like name is user one, email is user one example.com. The password is encrypted because we use here the bcrypt format for this securing the password. So by using token, we can access the data of that particular user also. So this is the decoding for this token, and we'll just go with my interface. This is my platform that I created here. So registration already done with this postman. So I will just check the all users is registered or not. There's a user one. So you have to check here the particular user is logged in or not for the platform. So is the username, just copy it and go to the login and paste it. And if I enter any random password, so it didn't allow me to enter into the dashboard. So I have to just go back with the postman. Where is my password? Password is the capital PASS at the rate 321. Just copy the password and enter here and click to login. So it is allowing me to log in successfully, and after filling this data, welcome to admin, like user one is here, means the particular user is logged in, and you can check the profile also with this name and username, means his email ID. So this is the authentication does for creating a platform, creating registration for the any specific platform or logging for this user. And now I can log out. Now after I will back and just log in, so I don't need to register again. The data is already stored to server. Just I have to create enter the email and the password, or you can say username and the password. The token will be verified, and they can enter you for the access control. So this is from token API testing or token. So I'm going to over to Shweta ma'am for this next top.
Thank you, Sahil sir. Now we will discuss what is auth authentication. Auth allows users to grant limited access to their accounts and data to third-party applications without compromising their passwords. Auth is an authentication protocol that allows two applications to communicate and share data without providing users' password. It decouples authentication, verifying a user's identity, from authorization, determining what a user can access, or enhances online safety by enabling secure data sharing and access delegation between applications. It uses authorization token to prove an identity between consumers and service provider. It acts as an intermediary on behalf of user and provide access token to the application so that they are authorized to share specific account information. Now we will see why we use auth authentication. Auth is an industry standard protocol for API authentication with many advantages such as improved security, better user experience, and scalability. Now we will discuss the workflow of auth authentication. Firstly, we will discuss about the OAuth terminology. Here we see a client. The client is the application that wants to access some data. Then we have here a resource owner. This is a user that has a data on this resource server. Then after we see here authorization server, the server that manages access issues and access the token to the client. Then we see here resource server, the application that stores the data that client wants to access. Now we see the workflow. Here we have a client that requests for the authorization to the resource owner. The resource owner then gives a permission to the authorization to the client. And after that, the client gives passes that authorization grant to the authorization server. Then after this process, the authorization server gives access token to the client. When the client receives that access token, then the client gives that access token to the resource server. And when this resource server gets, then the resource server validates that access token with the authorization server. If it is valid, then it will gives access of the protected resource to the client. Now we will see the auth authentication with an example. Here we have a resource owner and the client as a Spotify. Then we have authorization server as a Facebook and resource server, which has the profile details of the user. Here, the user wants to create an Spotify account. Then he has his profile details in the Facebook account. Then the client asks for users permission to use his Facebook profile details, and user accepts the request. Then the client request for the authorization with the scope. Scope is a permission that a user can grant to the application. Then the goes to the resource owner for authentication and user consent. User consent is a user permission to allow the user's application to perform certain action on access specific data on their behalf. Then the authorization goes to the client for with access token and refresh token. Access token is has a limited validity. In that case, refresh token is used. The client gives the refresh token to authorization server. Then the server will issue a new access token. That access token app has to give to the resource server to access the resources. Then after that, the client application uh, gives a request resource along with the access token, and then the resource server with access token goes to the authorization server to verify the access token. This process we call as an introspection. And when the access token is verified, then the resource server will give access resources to the client, and the client can access the resources anytime it wants without contacting the authorization server. Now we will see the advantages of auth authentication. Simplified user experience. Auth enables users to access multiple applications and services without providing usernames each time. The next we see enhanced security. It allows users to grant limited access to their resources without revealing their login credentials. It reduces risk of unauthorized access and password theft. Then scalability and interoperability. It enables seamless authentication and authorization across different platforms and services. Then we see here user consent and control. The user have the ability to grant or revoke access permissions for specific application and services. Then the next advantage is single sign-on SSO capability. Auth enables single sign-on functionality, which means that once a user is authenticated with one service, they can access other services without needing to re-enter their credentials. Then there is a developer friendly. Auth provides a standardized and well documented framework for authentication and authorization. Then we see here third party integration. This promotes collaboration and enables the development interconnected system of applications. That's all from my side. Now Nilima will explain API key authentication. Over to you, Nilima.
Thank you, Shweta ma'am, for the good demonstration. Good afternoon, everyone. My name is Nilima Yadav. Now I am going to explain what is API key authentication. API keys are used for API authentication in a wide range of applications from mobile apps to enterprise SaaS products. API keys are secret tokens used to authenticate API requests. They usually consist of public key and a private key, and they help API providers identify the API consumer, and grant them access to API resources. API keys are generally sent as an HTTP header in API request. Now you will see. Now we will see how why we use API key authentication. API providers can easily revoke API keys when needed, and API consumer can generate new API keys if the existing ones become compromised or outdated. API keys are fast and easy to use, and they provide flexibility. It involves providing a unique API key with each request, which can be easily included as a query parameter or in the request header. Now we will see how to use API key authentication. User creation, an actor create an API key, then API request submission, the user submit a request with the API key to the server. Then M2M application creation, the API create a machine to machine application by the API key management. Then client secret storage, the client secret is stored in a database along with the primary key of the API key. Then API key validation. The API key management API validates the API key and returns the client ID and secret. Then token exchange. The user exchanges the client ID and secret for a token from the API key authentication. Then service access. The token is then used as an authentication mechanism to access the desired service. Now we will see advantages of API key. It can also be used for authorization like barrier tokens and OAuth. API keys can both authenticate and authorize API access since they are specific to an application and not to the user. They can easily be included in scripts for programmatic access. They facilitate easy programmatic access for your user. Now we will see which is better to use for authentication. According to the need, we have to select right API methods. If you need basic security needs, then we use basic authentication. For improved security, use token authentication with HTTPs, considering adding token expiration for added security. For delegated authorization and fine-grained access control, use OAuth authentication. This is particularly beneficial when your API involves third-party integrations or access control delegation. For simple and low security use cases, use API key authentication with HTTP. Thank you. Now I will hand over to API testing team to provide brief information.
Hey, good afternoon, all. Here, as a team member of API testing, I'm Nutan Sanwani from Axiom TechGuru Pvt Limited. Now we move towards API testing. API testing is a type of software testing that involves testing application programming interfaces directly and as part of integration testing to determine if they meet expectations for functionality, reliability, performance, and security here. API testing is the process of confirming that an API is working as expected. Developers can run API tests manually or they can automate them with an API testing tool. There are several types of API tests, and each one plays a distinct role in ensuring the API remains reliable here. The purpose of API testing is to check the functionality, reliability, performance, and security of the programming interfaces. See, what are the benefits if we see? Various benefits API testing provides, like early testing, swift feedback, cost efficiency, security, easy integration, interface independent. Here, swift feedback is nothing but improved test feedback for the specific module it gives. Now we move towards why is API testing very important and mandatory for all of us in programming. See, API test design includes test design techniques like equivalence prioritization, boundary values, state transition testing here. Test coverage is also included, creating effective test cases. Like if we see in gaming steps, it's like that only. We write effective test cases. Now, writing test code, which code is in a Python only. So, this kind of designs test steps it provides. Today's software landscape is highly competitive, and users are increasingly unwilling to tolerate unreliable applications here. An issue at an application's API layer can lead to user facing error or latencies, which can erode customer trust, lead to churn, and negatively impact the business here. With respect to security, with respect to testing, this puts enormous pressure on development team to deliver APIs that are consistently available and highly performant here. Many teams have chosen to tackle this challenge by adopting the API first development model, in which applications are conceptualized and built as a collection of internal and external services that are delivered through APIs. This strategy treats API as a crucial infrastructure component, which makes API quality a top priority here. API testing plays a central role in the API first approach, as it enables teams to continuously verify the quality, health, and performance of their endpoints as they work to deliver a seamless digital experiences. So if we see how to perform API testing, there are various kind of commands and guidelines provided here. If we see a roadmap regarding, or we can say it as a workflow of API, it includes get, post, put, delete, and patch over here. It's related to HTTP commands like hypertext transfer protocol commands. Get include reading, post include creating, put include updating, delete is as known as deleting a particular we can say path, and patch include update and existing resources over here. Through this particular commands, you will knowingly the purpose of API will set a firm foundation for you to well prepare API testing data for input as well as output. It prepares particular test data with respect to input and output, and this helps us to define particular verification approach here. If we see to illustrate the analogy, if we consider API testing as a charting a route on Google Map, we see a step-by-step process. First step, you understand your start and end point, and any stop you want to make here a particular one. It's like or it's similar to understanding the API and planning test. Second one, then you ensure your device has a good internet connection and GPS signal. It's like setting up the environment for a particular process. Third one is you then follow the route Google Map gives or provides. It's like executing the test cases or test. Now, next one is finally you check if you have arrived at your destination correctly. It's like analyzing the results or analysis the particular result steps. Now, next one, if you took a wrong turn or encountered a road block, you would correct your course and continue. It's like addressing issue and retesting again and take a particular path. These are the steps. Now, if we see, we have a types of API testing tools like REST, Assured, Postman, Catalan Studio, JUnit, Apache JMeter, and SOAP UI. From this, some are, we can say, automation testing, some are open source tools we have, some are specific language like Java developer. If we see JUnit, it's like a Java used by a Java developer only. So we have such kind of tools for API testing. Now we go with the preparing for API testing. uh, it has a various steps: choose a testing tool, then writing test code, interacting with the API, then validating. Choose a testing tool. If we see, similar to picking the right tool for a task, select a suitable testing tool like Postman, Advanced REST Client, or curl to interact with the API and send request. If we see writing test code, it's like preparing study material. You must write code to test the API here. This code will help you send request and validate the API's responses. It's like a client and server, like a request and response kind of communication. Interacting with the API, if we imagine having a conversation with the API here, use the testing tool to send different requests, such as HTTPs. As I told you, this particular commands like get, post, put, delete, and patch over here to check if the APIs function correctly or not. If we see validating, the API's output is like checking your answer after solving a problem. It include validation or assertion in your test cases to ensure that the API produces the expected output or results here. Now, if we see types of API testing, it includes smoke testing, functional, integrational, regression, load, stress, security, UI, and fuzz testing. That is the total. We can say nine testings are there. We see one by one. Smoke testing, also called build verification testing or confidence testing, is a software testing method that is used to determine if a new software build is ready for the next testing phase or not. This testing method determines if the most crucial function of a program work but does not delve into finer details here. It's just an overview of testing, we can say. Functional testing, if we see purpose of this particular testing, it confirms that the API function according to its specification and requirements. Test input parameters, output responses, error handling, and overall behavior to ensure correctness and reliability here. It also, we can say, in a particular tree of security here. That's why the reliability and error handling capability is there. Integration testing, purpose of this, validate the interaction and integration between various components, including APIs, databases, servers, and external services. It ensures that the API communication and function correctly when integrated into the overall system. Now we move towards regression testing, and purpose of it, it ensures that changes, updates, or enhancement to the API to not introduce new defects or regressions. Validate that existing functionality remain intact and it's good for particular, we can say, module. And the API maintain compatibility with other component after modifications here. Load testing, if we see, its purpose is to evaluate the performance and scalability of the API under expected load conditions. It determines its response time throughout resources utilization and ability to handle concurrent user requests without performance degradation. It checks particular performance need to be consistent, and it gives a consistent result, so that load need to be maintained here. Stress testing, if we see, it has assessed the robustness and stability of the API under extreme conditions such as high load, resource constraints, or unexpected input. It identifies potential failure point, bottlenecks, and system weaknesses and manage it properly. If we see security testing, if we see purpose of it, identify and mitigate security vulnerabilities and risks in the API, such as authentication flaws, authorization issues, and data exposure, injections attack, encryption weaknesses, and protection against common security threat. See, my one of the colleagues, Sahil, explain you about the security API keys. It's related to that only. We have authentication, basic securities here, and we have various previously we have various algorithms for it which integrated into the apis like caesar cipher. If we talk about md5 here, if we talk about public and private keys and security keys over here, it all gives us a security regarding the particular moduling and security towards our we can say code as well as the testing. Now we move towards UI next testing, that is the UI testing. User interface testing is a type of software testing that focuses on checking the appearance, functionality, and usability of different kind of user interfaces, such as graphical user interface, command line interface, and voice user interface. Now, last but not the least, that is the fuzz testing. That is the fuzzing is an automated software testing method that injects invalid, malformed, or unexpected input into a system to reveal software defects and vulnerabilities. A fuzzing tool injects this input into the system and then monitor for exceptions such as crashing or information leakage, so that we monitor it and find the if we it has information leakage or crashes previously, so that we can take we can say it as a secure or protected action against it and set as a priority of it. Now, that's it from my side. I hand over to Swapnil for further topic regarding API testing.
Yes, thank you so much, ma'am. Now we will start with the API testing and API monitoring. So let's start with the API testing. Firstly, we will go with the API testing. The API testing is a type of software testing that analyzes an application program interface that stands for the API to verify that it fulfills its expected functionality, security, performance, and the reliability. The tests are performed either directly to the API or as part of integration testing. So, in this, the PS stands for the perform programming interface. Programming interface testing and the API monitoring shares the goal to ensure that API remains reliable and the performant, but these processes are typically performed at different stages of the API lifecycle. So API testing occurs during development and its primary purpose is to help team catch issues before they reach production and impact users. So the API monitoring. The API monitoring refers to the practice of monitoring application programming interfaces, mostly the commonly used in the production process to gain the visibility into the performance, the availability, and the functional correctness. So the API monitoring may utilize the same testing logic, but it occurs after the API has been deployed to production. The API monitoring also involves gathering and visualizing the API telemetry data. Here, the telemetry data means the automatic process of the data created by your system being remotely collected through the use of the agents and protocols. So, which team can use to perform historical analysis and surface long-term performance trends. So these are the few API testing can typically detected software bugs. These are the few bugs. So we need to reliability issues may be there in API testing, the responses time, the duplication of the functionality, and maybe there is lots of requests done by the tester. So there must be problem in the exceeding request limits also, in incompatible error handling mechanism also there, uh, incorrect error and the warning, the incorrect structure, response data, missing functionalities, multi-threading problems, security problems, and also the unused flags also. And also it helps to catch the bugs early before the cause problem in the final products. API testing enhance security by checking the API authentication, authorization, and the data protection. It validates performance metric like response times, ensuring the system run efficiently and can handle a lots of users. So these are the best practices for the API testing. Firstly, we need to go the group testing case by the category, which defining them, and also we should include the selected parameters in the test cases. Also, we need to develop the test cases for every potential API input combinations, and we need to reuse and repeat the test cases to monitor the API throughout production process. Use both manual and the automated testing to produce better and the trustworthy result. When testing the API, note that happens consistently and what does not. So we will use the API load test to test the stress of the system. The system may load, which when testing failures, an API should be tested so that it fails consistently in order to isolate the problem, perform call sequencing with a solid plan in the place, ace testing by prioritizing the API functional calls, also use a good level of documentation that is easy to understand and automate the documentation process as much as possible. Keep each test cases self-contained and separate from the dependencies if possible. So these are the test cases for the API testing. Return value based on input condition does not return anything, trigger some other API events, interrupt, update data structure, modify certain resources. So we will go one by one. So firstly, return value based on input condition. It is relatively easy to test as input can be defined and the result can be authenticated. Does not return anything when there is no return value or behavior of API on system to be checked. In the trigger some other API, like if an output of an API triggers some event or interrupt, then those events and interrupt listener should be tracked one. And also we should update data structure. Updating data structure will help you to overcome from the effects of the system, and that should be authenticated also. And we need to modify certain resources. If API call modifies some resources, then it should be validated by accessing respectively resources. So these are the it uses the API testing like the tablet, web application, game console, mobile devices, smartphones, connected car, connected appliances, also websites, enterprises, partners. They all are integrated from the API. So these are the few references. Thank you so much. Now I hand over to Mr. Sahil. He will give a short demonstration on the API testing. Thank you.
Thank you, Swapnil sir, for your demonstration. Hello everyone, I'm back here to give a demonstration of API testing. Let's share the screen. Hope you are seeing my screen as well. So already we have to know about what is CRUD. Already my colleague Swapnil sir already tell about the testing. I'll just give you the brief of create read update. What is the use of keywords for the testing purpose? Create is for the post, read is for the get. For updating any data, we use put method, and for deleting, we use delete. So let's, and these are the HTTP methods for creating and testing the APIs. So just we will go for the Postman here. Here we already executed some testings. So just for we'll go for the posting. First method is the post. Here we have the URL like the localhost. The port name is 5000 and the use is the router. And in that router routes we have the endpoint like register. And in the body section we have to select the raw and we have to send the data like this name, email, and password. So just I will update that with two. Okay, So these are the credential. So we have to just test that the APIs are working or not for the method using post. So we have to just send the request to the server, and in the response it will show you the status is okay and token is generated, means the first API and first method of post is working. By using this, we can go with this platform also. Here's the first session. So by using the front end, we can register also. So just here, test to fill the credentials here and the password for the new registration, and just submit it. So it is also showing that the data is submitted successfully. Means the first method of post is working properly, and you can see it all the registration here, the user 2 and the test 2. User 2 created by using Postman, while I am creating the and using the method, and test 2 is created by the front end. It is the internal APIs which is we use here. And just we will go with the Postman again for the login. First we will get the access of all the data which is showing here, means all users. So we'll test that data is showing or not. Okay, so we have to change the method here. From I already selected get, you can select from here also. And this is the URL. You have to check the endpoint. I already told about this is the endpoint which is matters to execute the your request to the server. So here is the all user, and just I have to click the button on the send to request to server, and it will give me the response as a data of all. You can see here test and the user means the already stored here, but new data is like user 2 and the test 2 we are getting here, means the APIs are working. And this is the small demo of API testing here. And now it's time to move forward and get know about how companies ship code to production. So just I'm over to you, team. Thank you.
Thank you, Sahil sir. Good afternoon, everyone. The title of presentation is How Companies Ship Code to Production. Today, we are diving into the heart of modern software development, the journey from code creation to the production deployment. In our fast-paced digital world, the ability to swiftly and reliably deliver code to production is key for companies aiming to innovate and stay competitive. Throughout this presentation, we'll explore the strategies, methodologies, and tools company employ to ensure smooth code delivery. From meticulous planning to automated testing and deployment, each step in this process is essential for maintaining quality and efficiency. The intricacies of code deployment and uncover the secrets behind successful production shipment. Let's start. Software code shipping cycle. This process encapsulates the end-to-end journey of software from planning to release. It means end-to-end software development encapsulates the entire life cycle of the software application, going from the definition of requirements, concepts, and designing through deployment to testing and maintenance. It under it underscores many tools and processes that ensure software is not only functionally but also meets quality standard. Here, during the testing phase, you can ensure quality standards are met by creating a comprehensive test plan, executing throughout testing, documenting and addressing any issues found, and seeking feedback from stakeholders. By comprehending this workflow, business can better navigate the digital landscape, ensuring that they deploy code both safely and efficiently to production, which means deploying code is the process of moving code change from a development environment to a production environment where it becomes accessible to user. This typically involves a series of steps include testing, building and release the code. Hope you understand. This is a flow structure which we used in entire presentation contain five phases: plan, development, build and package, test and last is release. Let's start with plan. At this foundational stage, vision become tangible task. On this phase, product owner gather requirement, create and estimate user stories with team, prioritize them, and make risk assessment. Transforming overenhancing product goal into detailed user stories is the core activity here. Task tracking we used both Jira and Trello. It provides powerful task tracking capabilities, allowing team to create, assign, and track tasks throughout the development process. Tools like Jira streamline this process, enabling better tracking and organization. These tools enable team to set priorities for tasks, ensuring that the most critical feature or requirements are addressed first. User story representing specific functionalities from the user perspective can be defined and managed with Jira or Trello, helping team understand what need to be built. Confluence often used for documentation. Confluence serves a criticalized platform for a documenting project specification, requirement, and other important details. Also, the team can collaborate on documentation in real time, ensuring that everyone has access to the latest information and can contribute the defining project scope and requirements. A well throughout plan provides clarity, reduced ambiguities, and ensure that every team member understands their role and responsibilities. It acts as a reference point for further steps. Communication tool facilitate communication between team member, project manager, and stakeholder. Real-time messaging like instant messaging feature allow for quick and efficient communication, reducing the need for lengthy email threads or meeting. Integration with other tools, Slack or Microsoft Team can be integrated with project management and documentation tools like Jira, Trello, and Confluence, streamlining communication and collaboration workflow. Hope you understood. For the further phase of development, I would like to invite Ms. Meenal. Thank you.
Hello, good afternoon, everyone. Myself, Meenal Sonsare from Axiom team. Let's discuss about the second step of how companies ship code to production, that is development. What is development? In development, our ideas turn into functional code. As we take user stories from Jira tool, developers perform several actions such as task analysis, coding, version control, continuous feedback, peer review, automated system, prototyping and mockups, and integration. Now, let's discuss about task analysis. Task analysis means complete study of user to successfully complete the task. Before diving into coding, developers spend a considerable amount of time understanding and analyzing user stories. This ensures that they have a clear vision of what needs to be built and the value it provides to the end users. Coding. Post analysis developers employ various programming languages and tools tailored to the project's requirement. Then, version control means change manage changes to the source code over time. As code is written, it's essential to track and manage changes. Now let's move to continuous feedback. Any feedback that is delivered on regular basis, the development process isn't isolated. As code is committed, feedback mechanism activates. Peer review, it is to read, check, and give the opinion. Fellow developers review the code to spot logical errors, ensuring code standards and validate the approaches. Automated system tools like linters and static code analysis provide intermediate feedback about code quality. Linter tool is used to fix technical issues and static code is used to analyze source code. Prototyping and mockups for user interface intensive application developers might create prototypes or mockups. This helps in visualizing the end product and facilitates better user experience design.
Lastly, integration. As modules or features are developed, they need to be integrated with the existing code base. This steps ensures that new additions work in harmony and previously developed parts. Now, we'll discuss about which tools are used. This is where version control system like Git plays a monumental role with platforms like GitHub, GitLab, or Bitbucket. Developers can collaboratively work. Let's talk about GitHub. GitHub is a platform for hosting code, version control. GitLab, it provides free, open and private repository. Bitbucket is used for code hosting and collaboration. Goal of developer is it is where theoretical concepts transition into practical implementation. Example, developers write code for the login features, push it to GitHub for review and incorporate any feedback received. Now, would like to call Ujjwal for build and packages. Thank you.
Thank you, Minal. So, as per the flow chart, let us understand about build and packages. First of all, what is build and package? It's a time to compile the code and get ready for deployment. We will take the code from GitHub and apply some continuous integration tool. So, firstly, let us know about continuous integration tool. Basically, continuous integration tool is a DevOps software development practice where developers regularly merge their code changes into a central repository, after which automated builds and tester runs. Then some tools like Jenkins, JUnit, JCoco, and SonarQube are used. So what is Jenkins? Jenkins is a self-contained open source automation server which can be used to automate all sorts of tasks related to building, testing, and delivering or deploying the software. Jenkins can be installed through native system packages, Docker, or even run standalone by any machine with a Java runtime environment installed. So there is a question arise: what is Docker? Docker is a tool that Docker is an operating system for containers. It is installed on each server and provides simple commands that we use to build, start, or stop the container. Then what is JCoco? JCoco is used to measure and report how much of your code, Java code, is executed during the execution of your test or business code in environment. JCoco code coverage can be achieved by different ways like Maven plugins for unit test. The focus of JCoco is to provide a lightweight, flexible and well-documented library for integration with various builds and development tools. So then SonarQube. SonarQube is a self-managed automated code review tool that systematically helps you deliver clean code. SonarQube integrates into existing workflow and detect issue in your code to help you perform continuous code inspection of your project. Then JUnit. It's a unit testing source framework for Java programming language. Java developers use this framework to write and execute automated tests. Then after applying all the tools, we will store it in a JFrog artifact. JFrog is a tool the- which store JFrog is a tool which store all the trusted it delivers trusted software at speed. The only software supply chain platform to give you end-to-end visibility, security, and give you control for automating the deliver of trusted release. The massively scalable hybrid JFrog platform is open, flexible, and integrated with all the technologies and tools comprising the software supply chain. Then after this, we will deploy the code to dev environment. So let us know about dev environment first. Dev environment let you create a configurable developers environment with all the codes and tools you need to quickly get up and running. It's a tool built in a code editor that allow Docker to access code mounted in a container rather than your local host. Then let us know about the fourth phase, which is test. So in test, we deploy the code from dev environment into QA environment. After the code deploys into QA environment, it will go through some tests like QA test, regression test, and performance test. So QA test is a process where developers used to verify and assure the quality of software product or services before releasing it to customer. The primary aim of QA testing is to verify if a product meets customers' requirement and specification. Regression testing. Regression testing ensures that the software has bugs has been successfully corrected by retesting the modified software. Then performance testing. Performance testing is a non-functional software testing techniques that determines how the stability, speed, scalability, and responsiveness of an application holds up. Then after this testing, it will go through UAT. UAT means user acceptance test. It's the final stage of any software development or change a request cycle before go live. Hope you are understanding well. Now for the further phase of release, I would like to invite Ms. Shyamal. Thank you.
Thank you, Ujjwal. Let's discuss about the phase release. Finally, where the software meets its user. Rule is site reliability engineering. Deployment to production. The package software, after cleaning all testing stages, is introduced into the productive environment. Monitoring one life, the software isn't just left to its own device. Monitoring tools are kept on its performance and behavior. Alerting and issue resolution. With the help of monitoring tool, any anomalies or unexpected behavior are promptly detected. Now, for the overview of code shipping, I would like to invite Ms. Meenal. Thank you.
Here are the 10 steps overview for how companies ship code to production. Step 1. The process starts with the product owner creating user stories based on requirements. Step 2. The development team pick up the user stories from the backlog and put them into a sprint for a 2-week development cycle. Step 3. The developers commit source code into the code repository Git. Step 4. A build is triggered in Jenkins. The source code must pass unit test, code coverage threshold, and gets in SonarQube. Step 5. Once the build is successful, the build is stored in Artifactory. Then the build is developed into the development environment. Step 6. There might be multiple development team working on different features. The features need to be tested independently, so they are developed to QA1 and QA2. Step 7. The QA team picks up the new QA environment and performs QA testing, regression testing, and performance testing. Step 8. Once the QA builds pass the QA team's verification, they are deployed to a QAT environment. Step 9. If the QAT testing is successful, the builds become release candidates and will be developed to the production environment on schedule. Step 10. SRE Site Reliability Engineering team is responsible for prod monitoring. Hope you understand how companies ship code to production. Thank you.
Hey, thanks Team Axiom. It was really wonderful exhibition of various topics. Uh, what you put it as a for the live stream. For all those decades who want to establish their career or they are working professionals, we need to keep exploring these all the topics so that as we know that industry going to update with technologies with 200% pace and every year. So we all need to get updated with a or upskill ourselves with the updated latest leading technical trends. Hope you enjoy these discussions and elaborations with Team Axiom. If you need uh, some topics or some like newly technical trends want to discuss with the Team Axiom, do join us. Together we will explore new technical trends to make ourselves industrial, uh, like tech savvy for industrial solutions. Hope you enjoy this live streaming. Thank you very much. Have a good day ahead.